Welcome to The Explainer. I am absolutely thrilled you're here. Look, today we are digging into a massive, and I mean massive leap forward for professional developers. We're talking about OpenAI's December 25 release of GPT-5.2-Codex. Now, if you build software for a living, you know that real engineering is almost never just about auto-completing a single line of code, right? It's messy, it's sprawling, it takes hours, sometimes days. And that is exactly the problem this new model was engineered to tackle. It is built specifically for professional software engineering and long-horizon tasks. So let's just dive right into this.
Right off the bat, to set the stage here, let's look at this TLDR directly from the source. It reads, GPT-5.2-Codex, a version of GPT-5.2 optimized for agentic coding with better long-horizon work, large-scale refactors, Windows environment support, and defensive cybersecurity capabilities. This drops us right into the core of what this thing actually does. It's not just a chat assistant waiting for you to type. It is an agentic operator designed to literally sit in your terminal, navigate your files, and execute incredibly complex workflows all on its own.
So here's the game plan for today's explainer. First, we'll meet GPT-5.2-Codex. Second, we'll look at the context compaction breakthrough. Third, we'll cover the new Windows and cyber upgrades. Fourth, we'll check out its SWE-Bench performance. And finally, we'll talk about actually building with the agent's SDK.
All right, part 1. Meet GPT 5.2 Codex, engineered for the long haul.
Released on December 18, 2025, this model is a very targeted evolution. Standard large language models, they're great at single-turn code completion. You ask for a quick function, you get a function. But GPT 5.2 Codex is explicitly targeting long, multi-step professional workflows. We are talking about massive repository operations and really intense defensive cybersecurity work. It's literally designed to navigate through a code base, make a plan, run the tests, watch those tests fail, and then actually iterate on a solution without you having to constantly hold its hand.
Moving right along to Section 2, the context compaction breakthrough. Remembering the plan.
Okay, so the absolute biggest friction point in agentic coding, and we've all seen this, is when the AI just loses its train of thought right in the middle of a massive task. Well, enter context compaction. This is a technique allowing models to maintain a coherent state across extended sessions and massive code bases without losing that earlier context. Think about it like you, a human developer. When you're 3 days deep into some massive system refactor, your mental stack has to remain intact, right? You have to remember why you made a weird change on Tuesday to fix a bug on Thursday. Context compaction essentially gives the model that exact same persistent mental stack.
And this visual brilliantly illustrates the difference. Over on the left, without compaction, earlier models would frankly just run out of working memory, or they'd lose track of their core instructions mid-task, basically failing entirely on something like a 200-file migration. But on the right, with context compaction, GPT 5.2 Codex maintains this coherent state across dozens and dozens of tool calls. If a plan changes or if an attempt fails halfway through, it doesn't just throw its hands up or start hallucinating. It keeps iterating while keeping the entire project scope totally intact. It's a real game changer.
Up next, Section 3, Upgrading the Environment, Windows and Cybersecurity.
Because let's be real, a smart model is pretty useless if it can't run reliably in your actual enterprise environment. Historically, a lot of agent coding tools just assumed they were running on Linux or Mac OS, which meant they behaved really erratically on enterprise Windows machines. Well, GPT 5.2 Codex explicitly fixes these native Windows terminal issues. It moves past those old POSIX assumptions, which makes this tool immensely more reliable and relevant if you're part of a dev team standardized on Windows.
Now, alongside those OS upgrades are some significantly stronger cybersecurity capabilities. But OpenAI has structured this really carefully. As you can see, general developers get access to the standard, incredibly robust toolset. However, for complex defensive code audits and deep vulnerability research, there's a new trusted access tier, and that actually requires a strict vetting process. The focus here is entirely on empowering security professionals to defend their systems, not just releasing general availability tools for offensive exploitation.
Which brings us to Section 4, SWE-Bench Performance Realities. Let's look at the global scoreboard.
Because look, promises are great, but performance is what actually matters, right? These benchmarks test agentic performance on real, messy, complex GitHub issues. 72.8%. Let's that sink in. That is GPT 5.2 Codex's resolution rate on the SWE-Bench verified leaderboard.
Autonomously solving over 70% of real-world issues is a huge achievement, and what's really wild is that it does it efficiently. We're talking an average cost of just 45 cents per run.
But let's zoom out and look at the broader competitive landscape. Now, GPT-5.2-Codex is OpenAI's state-of-the-art model. However, on the objective global SWE-Bench scoreboard, Claude 4.5 Opus is actually sitting higher right now at 76.80% resolved, though it does come in at a higher average cost of 75 cents. Then you have Gemini 3 Flash resolving 75.80% at a super cost-effective 36 cents, and then GPT 5.2 Codex resolving 72.80% at 45 cents. So it's a fiercely competitive space right now for sure, but this firmly plants OpenAI right in that top tier of enterprise-grade, cost-effective agentic performance.
Finally, Section 5, Building with the Agents SDK, taking this from the docs to deployment. Because it really comes down to this core question. What should developers actually do with this? If you want to move beyond just a simple chat interface and actually orchestrate this model in real-world custom applications, you're going to need a structured framework, a place where your server owns the orchestration, the tool execution, the state, and the approvals. Well, the Agents SDK documentation outlines a very clear, logical flow for building a code-first agent app. It's essentially 4 steps. Step 1 is the quick start, literally just getting the SDK installed and a single run working on your screen. Step 2 is defining your agent specialists. This is where you shape the contract for a single, highly focused agent. Step 3 is orchestration and handoffs, figuring out how different agents talk to each other and who actually owns the reply. And finally, Step 4 is capturing results and state. This is where you effectively utilize that context compaction we talked about earlier to manage resumable states across those massive, long-horizon tasks.
And to empower those agents, the SDK gives you some absolutely incredible architectural plugins out of the box. Just look at this toolkit. You can give your agent web search to go out and find up-to-date documentation. You can set up secure MCP tunnels. You can grant it local shell access to run commands, or even full computer use capabilities. It can perform deep file search and retrieval across your entire repo, and then use the Apply Patch tool to actively write and fix the code. These are the concrete tools that literally turn an LLM into an autonomous engineer.
So, if you're itching to test this today on your largest, messiest refactor, which, let's be honest, is the ultimate benchmark, the installation path couldn't be easier. It is a single terminal command, npmi-g at OpenAI/Codex. Boom. That pulls down the tooling you need to get this model running right in your own environment.
Okay, we have covered a lot of ground today, from context compaction to SWE-Bench scores to the Agents SDK. But as we wrap up this explainer, I want to leave you with this final provocative thought. As models like GPT 5.2 Codex gain this kind of deep memory and native OS reliability, what part of your engineering workflow will you automate next? The tools are now officially here to build incredibly complex, multi-step agentic applications. I really hope this helped clarify exactly how you can start doing that. Keep learning, keep building, and I will see you next time.